It's time to chill out and get ready for a mediocre Q&A live stream. If you're old enough, grab yourself your favorite adult beverage, and if you're not, stick with apple juice. Put your feet up and relax. If you have any questions, feel free to ask them in the chat. And now let's cue up the intro music. What is up, everybody? Welcome to the HVACR videos live stream. I'm your host, Chris. Here I am. I'm here. It's been a while. Skipped at least one stream, maybe two. I don't know. Things have been getting busy. You guys understand. It's summertime, right? Work, life, family, all that good stuff. It almost didn't even happen tonight because I went to go log on and schedule the stream, and the streaming software that I use, which is StreamYard, they said there was a problem with YouTube. And so I was like, well, we'll see. So I just kind of got everything ready, and then whatever it was, they fixed it. So here we are. But welcome to the stream. So, the whole reason why I do these live streams is to consolidate the questions. We get a lot of questions on the videos and stuff, and a lot of them are repetitive, or some of them are kind of cool. And I figure, hey, it'd be good to address those where multiple people can hear it. So we do it on these live streams. The live streams turn into a podcast. You can download them from YouTube. That's the easiest place, best place. If I get off my butt and actually give my daughter some direction, she'll go and upload them to to the podcast app that I pay for. One of the things, as a random bit of information, because I'm just going to do this all the time. If you guys don't already know me, I go off on these tangents all the time where my brain's just like, hey, let's talk about this. Hey, let's stop talking about that and just start talking about this. And that's just how it happens. I'm sure it's like some undiagnosed ADHD thing or something like that. But I've been really thinking about something. And as a content creator, you end up, without even realizing it, subscribing to a bunch of different things. And I have so many subscriptions, and it's like, man, I need to rein all those subscriptions in. So somehow I got to figure this out. I got to scour my bank account and go through and see what reoccurring charges are happening or something to start canceling all this stuff, because I've got subscriptions on top of subscriptions for things that I probably shouldn't. And, it's just one of those things. I'm sure it happens to you guys, even if you're not doing the content creation stuff. It's really easy just to realize like, oh my gosh, I'm being charged for that. The worst is when I do, because oftentimes I'll do the one lump payment. So like if I'm subscribing to an app or something like that, I'll pay $200 for the year or whatever it is, right? To save $75 or whatever. They always give you a discount if you pay up front or whatever. But the problem is that then you're not seeing a recurring charge every month to annoy you. All just, a year from now, boom, there'll be another $200 charge or whatever it is. And you're like, oh man, But anyways, these are first world problems that we have going on here, right? Welcome to the stream. Hello to everybody. Lots of great people in here. Yeah, summer finally hit Southern California. We're still having some June gloom where it's cool in the morning, but we're getting our 95, 98 degree weather for sure. We really haven't pushed in my area. Now in the desert communities, they've pushed over 100. We really haven't pushed very much over 100 for very long, at least in my area. I live in the Inland Empire, which is probably about an hour and a half north of Palm Springs, which is the low desert, or about an hour and 15 minutes south of the high desert, which is like the Victorville area, Barstow, that area. Yeah, I'm in the Southern California Inland Empire region. So, all right, let's see what else we got going on inside the chat. Yeah, I know a lot of the country has been having this heat wave coming through and we're just barely getting it. So again, welcome to the stream. I hope that you guys had a great weekend, great Father's Day for those of you that are fathers or obviously celebrate with your fathers. I myself celebrated my birthday, turned 41 yesterday, and also Father's Day on the same day. So that was kind of cool. Got to spend time. My dad came over to my house. Instead of us going out to dinner, we barbecued at my house, which is so much more convenient, less stress, less everything. So it was really nice and hung out with the family and stuff. And it was just a good overall weekend. So super happy about that. Let's see. Thanks so much. All right. So, I have something that I talk about quite often in my videos, and that's the big picture diagnosis, right? The big picture approach. Take a step back, look at the big picture. There's a couple different ways that I'd phrase my little catchphrase, but I wanted to talk about a different thing about it. Why did the big picture approach come to fruition? Why did I start using the big picture, right? Taking a step back and looking at the big picture. It really happened because I kind of reflected on myself and realized that I was sick of the mistakes that I was making. I was sick of the callbacks that I was getting. This was probably 20 something years ago, and it was just starting to get ridiculous. I didn't like having to go back out to a customer with my tail between my legs, not knowing how to fix it, or, not fixing it right. And that's where I really started to think, like, how can I solve these problems? How can I eliminate these callbacks? And that was when I really started looking at the big picture, right? Assuming the worst. Okay. If you assume the worst, then you can only be happy, right? I mean, you assume that the worst is going to happen. There's not really much disappointment there if the worst does happen. But if it doesn't, then it's a bonus, right? So I kind of look at things and think, if it can, it will. So if it can happen, it will happen. For instance, something that I have on my list to talk about, someone mentioned, why they were being sarcastic, saying that they noticed that I am very organized in the way that, like, for instance, screws, when I'm working on a package unit, all the screws go into one particular place and they stay in one place because they don't stay on the ground. Because from experience, I know that if you put them on the ground, you will kick them and they will go everywhere. If you put them on a panel that can be affected by vibration, they will fall off and they will go everywhere. And then you will lose the screws for the equipment. That is a big pet peeve of mine. I'm sure my employees go nuts with me because I'm always asking them, where's the screws at? Where did you put the screws? Did you put the screw, like, constantly on top of them to make sure that they put everything, because it's something that drives me nuts. We're installing a new piece of equipment. There's no excuse for us to lose the screws, right? I tend to like hyper focus on things like that. And it's because I've made so many mistakes. I've lost the screws so many times. I've set them on top of the exhaust fan thinking maybe I shouldn't. Nah, it'll be fine. And the next thing you know, you come back and it's like, where did everything go? Vibrated, fell into the fan, shot across the roof. Who knows, right? So the big picture approach, though, it really was out of desperation, taking a step back and trying to prevent my callbacks. Now, something that has happened that was an unintended consequence, that was a good thing, is the big picture approach is still helping me to this day. Okay. However many years I've been in the trade, it's been a long time. the big picture approach is doing something different for me. My customers, a good majority of my customers, do not do any routine maintenance. There's a few of them that still do something, but a good majority of them do not do routine maintenance. And if they do any kind of maintenance, it's not with me. They'll have like national filter changing companies come through and change all their filters, but they're not service technicians, right? So we aren't out there doing a lot of preventative maintenance. We're not out there finding problems before they become problems. So when we are there for a service call, right? That's why it's so important. I say this all the time. Don't wear headphones when you're on the roof, right? Unless it's for hearing protection. You got to be able to listen to everything, listen to your surroundings, be hyper aware of what's going on around you. When I go up onto a rooftop, it is an opportunity to find more work, but not in a way that we're going to steal, we're going to cheat, we're going to be shady, none of that stuff. I'm literally just go onto the roof and with the customer's permission, hey, I'm here working on your AC. Do you mind if I just look at every other AC while I'm up there? I'm not going to spend more than 20 minutes. I'll just walk by, make sure they're working, look at the electrical section, look for any problems that maybe we could address before it becomes a real breakdown. So the big picture approach is now keeping me busy because when we're on the roof, it's like, hey, you might as well rinse off all the condensers if the customer's okay with it, because we're going to have the hose up there on the roof anyways. It's a process to get the hose up there and the coil cleaners and all that stuff. So we're there. Let's go ahead and rinse everything off, right? The customer gives us approval. We go up there, but then we find all kinds of work, right? Hey, while I was up there, I noticed this AC is, it's not working right. One of the fan motors is making a noise. It's going bad. I can address that. You can create a work order. We can come back. So the big picture approach is now, generating work for me and my employees have all kind of embraced it too. And they know that when we go out to a job site, as long as we're not like super slammed, do me a favor. It doesn't even matter if you're downstairs working on a reach and cooler. We all know at my company, you go, you talk to the manager, say, hey, I'm here. Do you mind if I pop my head on the roof? Just take a quick glance at your air conditioners and your refrigerators. Just make sure nothing funky is going on. Most of the time, I don't know if I've ever been told no. Almost all the time, they say, yeah, no problem, dude. Just jump up there. Let me know. And then I'll come down and I'll be like, hey, I found all these issues. You might want to have us look at this before it becomes a problem, before it becomes a 911. They don't always approve it, but most of the time they do. A lot of times I'm working for giant corporations where I have a single point in contact at the facilities department, right? So I'll reach out to a facilities director and say, hey, I was on site working on a reach-in cooler. With the manager's permission, I jumped on the roof and I found these other issues. Are these things that you want us to take care of? And most of the time they're like, yeah. Because even though the corporate office and these restaurants that I deal with, a good majority of the time, even though the corporate office doesn't want routine maintenance being done by service technicians, they want to use their national filter changing companies, right? It's just a game they have to play. The facilities department still knows that the equipment needs to be taken care of and they want us to take care of it. So they actually encourage us when we're there. Poke your nose around, go look at the walk-ins, look at everything, bring it to our attention. And so we do. So the big picture approach started as a thing out of desperation to try to eliminate service calls. And here we are, 20 something years later. And now it's helping to keep my company busy and keeping my guys moving. This is a very strange year for us in that the service calls are kind of weird. Customers are a little apprehensive about spending money because the economy is kind of whack right now. And, if I'm out there doing something, they appreciate us bringing this stuff up to them, because like I said, they're not doing that normal routine maintenance. So let's see what else we got going on. I'm looking through the chat right now. Magnetic screw dish works even vertically. Yeah, you know what? Magnetic screw dishes are great. And guys, I have so many tools in my van. And oftentimes when I do my van cleanings, I'll go and take a bunch of stuff out of my van that I never use. A magnetic tool dish, honestly, is kind of useless to me because most of the screws that I deal, well, not most, but some of the screws aren't magnetic, right? Depending on what you're working on. But the next thing is a magnetic parts dish is another thing for me to have to take onto the roof. It's another thing for me to have to carry up. I got enough stuff in my tool bag. And I know a magnetic tool dish probably weighs 9 ounces, right? But so does everything else that's in my bag. And it just all adds weight. So magnetic tool dish or screw dishes and stuff, like it's just another thing that I'm eventually going to take out of my van when it starts to annoy me. I try to be as minimal as possible. Even though my van is packed full of a crap ton of stuff, I pretty much use almost everything in my van. And if I don't use it, then when it comes time for a van cleaning, which doesn't happen very often, but I'll usually tear my whole van apart, I'll just be like, look, I don't use this. I could use this space for something else, so I'll ditch it. It goes in the abyss of my garage and then we move on. So, When they call you out, you're just triaging units. Yeah, pretty much. I mean, that, you know, for instance, this last weekend, I may or may not make a video out of this, or last week, I had a service call for an AC not working. The kitchen was hot. And then they said, you know, my bar is a little bit hot too. And I went there. It was some of the dirtiest condensers I've seen in a long time. Okay. I used 18, I'm not joking with you, 18 gallons of coil cleaner on top of a roof for 3 15-ton package units. 18 gallons. And even after I got one condenser cleaned, the water was coming through. It seemed fine. I turned it on. The unit was instantly going off on high head pressure. I had to clean it even more. It just kept coming. And it was just pure neglect of the customer not doing routine maintenance. So they got charged for 18 gallons of coil cleaner. That is so much coil cleaner. That might be my new personal record for the amount of coil cleaner used on one single roof. It was insane, right? And this is just a roof with 3 15-ton package units. It's nuts. Let me see what else we got going on in the chat. When a technician is called out, is he or she paid port to port? No, we don't pay port to port unless it is an overtime service call. So if it's a normal service call, we bill the customer travel time to the job, but we do not bill them travel time home. Therefore, we don't pay the employees travel time home. But if it is an overtime after hours service call, after 4 p.m. on a Saturday or a Sunday, then we charge the customer port to port, and the employee gets paid port to port. But the employee gets paid basically as technicians. We get paid from the moment we leave the office in the morning till the last call, the end of the last call, unless we're going into overtime. Then, you know, we don't get paid to drive home, basically. All right. Yeah, doesn't one bag make 9 gallons? That's insane. Yeah. Yeah, it wasn't 18 bags. It was 18 gallons. So it was 3 bags of coil cleaner, right? Using the right gun, but it was 18 gallons of coil cleaner. So, let me read through the chat right now. Who runs my office? We have a few people in the office. We have my dad that still works in the office. And then we have a secretary that's in the office. And then I go in between. I'm in the office a couple days a week for a couple hours a day, but then I'm out in the field almost every day too. So essentially there's 3 of us that work in the office, and then we have 3 service technicians out in the field all the time. And then I bounce between the office and the field all the time. Let's see. Jason says 18 gallons. The school system he used to work for when they lived in Michigan, you were reactivating a mothballed building that took 22 gallons. It was, yeah, that is nuts. That is absolutely nuts. So, all right, cool. Let's see what the next thing on my list is. Oh, good question. I get this one all the time. Am I a micromanager? So, or people will say, I hope you're not a micromanager, or they'll say, you sound like a micromanager. That's a horrible boss. You're a horrible person. Okay. The term micromanager, in the sense that most people think, you probably would agree that I'm a micromanager. Okay. But I don't really have a choice in the matter, because here's how this works. I, in my opinion, am successful with my customers because when they call me, I answer the phone. I usually pick up within the first or second ring. Okay. If I'm getting a direct call. If I'm getting a service call, those are a little bit different. But if I'm getting a direct call from a facilities director who will all call my cell phone direct, I answer within the first or the second ring. And when they ask me a question, I have the answer to that question. I feel like, in my opinion, my success with the restaurant chains that I have dealt with and the facilities departments in the corporate office is because when they call me, I answer. And when they ask me a question, I typically have the answer right then and there, even if it's about a service call. And that's because all of my technicians call me after they're done with the job just to check out, to say, hey, I'm all done. And they also call me throughout the day just to check in. If you're on a call, I typically tell them I want to hear from you at least every 2 to 3 hours. Just give me a heads up, say everything's cool, we're good to go. That way I'm not calling you at an inconvenient time. You call me when you're available to talk to me. You know, unless I need something, I'll call them. So am I a micromanager because I require my employees to call me and check out after every job? I mean, you tell me. Am I a micromanager because I know everything that's going on, so that way when the customer calls me, and they do on a regular basis, and they want to know what happened at that job, I have the answer for them, because that's how we run our business. So I don't know. Am I a micromanager because of that? I consider it to be, someone who's running their business the way that, keeps us successful and keeps everybody moving. I also am very concerned with quality, and my employees, they know the way that we want to do things. They know the way that we do things. They know what our reputation is, and we try to do all of our tasks to the best of our ability, right? And, when we do a walk-in install, I want them to, for the most part, all be very similarly set up, depending on the different brands and stuff. And I want the equipment installed properly, following the manufacturer's instructions as best as possible. Installing things following proper refrigeration practices as best as possible. So am I a micromanager for following the rules and doing things the right way? I don't know. You tell me. Let's see what else. Jason says, my company, my rules. Those that don't like it, make sure your resume is on point and updated. It's that simple. Yeah, and I don't really get much pushback from the employees. They know how to do things, and as long as they're getting it done and doing it right, I'm not calling them every 5 minutes to ask them every single point of the job. I mean, to the point that my dad still works in the office, so usually before I call an employee to check up on them, I'll call my dad and I'll say, hey, have you talked to this person today? Have you heard from them in the last couple hours? And he'll say, yeah, I did. They told me they're doing this. Boom. Okay, cool. I don't need to call him. I just want to check in and make sure everything's okay. But if he hasn't heard from him in over 2 hours and I haven't heard from him, then I'm going to just make a call and just say, hey, everything going okay? I just want you to check in. Just let me know how things are going, So that way I'm aware of what's going on. At the same time, I don't expect my employees to do, 50 billion service calls a day. And I don't give them 50 billion service calls at the beginning of the morning. We take it one call at a time. And, the on-call guy might have to work a little bit later, or everybody else in the summertime might have to pick up an extra call or something like that. As long as they don't got nothing going on, we're understanding. But, we basically let the guys do things and get it done to the best of their ability in the amount of time that it takes them, Now, I haven't had to do this in a very long time, but there's times too that like I'll look at an invoice and be like, that compressor change took way too long. I'll do a debrief with the guy, say, what did you run into? And he tells me this, and I'm like, in my head, I think, what? That took a little too long. So we'll subtract, some hours from the bill, but the employees are always going to get paid for their time, just depends on every situation. And then we'll work on it. Pat, thank you very much for that super chat, man. You didn't need to do that, but that is very much appreciated. That's Pat from Commercial Kitchen Chronicles. Thank you, bud. That's really nice of you. And thank you for the happy birthday wish. Okay. Heatcraft walk-in evaporator with an EEV, Jesse says. He's a newer tech, 1.5 years old. He's been struggling the past couple weeks with electrical issues. Can I give some tips and advice? Yes, I can. I can give you some tips and advice on the Heatcraft walk-ins. Give me just 1 second. I'm reading through something right now. Okay, cool. So it was you that asked a Heatcraft question earlier too, because I had it starred on my thing to go through it. So Heatcraft smart evaporators. They have 3 different smart evaporators. You have a beacon system, you have a QRC system, and you have an intelligence system. And I have heard of people having a lot of issues with the EEVs and the EEV cables. Your original question, do I have those same issues? And cross my fingers, no, I have not. I've installed a countless amount of Heatcraft equipment, and I haven't had EEV cable issues or weird things like that. The biggest piece of advice I'm going to give you is follow the installation instructions as best as possible. Independent power sources for the evaporator. Make sure if the restaurant has dirty power, they got to have some sort of power conditioning, surge protectors, or something like that protecting the equipment. That's a really big thing. Make sure you're using the proper cables and the proper wire gauge when you're installing power to the evaporators and different things, and just do your best. Now, again, I have heard a lot of people talk about the EEV failures and the EEV cable problems. I personally have not had those problems, and I have a lot of equipment out there. I don't know what it is and why everybody, that I've talked to that has had these issues. I don't understand what the problems are. I don't know, but I will say that Heatcraft typically has really good tech support. So I would definitely reach out to their tech support department and ask them. Okay. Make sure when you're installing the EEV cable, there is a specific direction that you have to install it on the stator. You have to make sure it's installed in the right direction. You can jam that cable on the wrong way and it will make the valve operate erratically. Okay. Make sure that you're following the user guide, the installation manual for the Heatcraft equipment in your troubleshooting diagnostics when it comes to ohming out the coils at the different temperatures or the stators, doing that. That would be my best bit of advice. Just make sure you're following the installation instructions to a T. Make sure the equipment is sized appropriately, right? And that's really important because if your equipment is not sized correctly, then you may or may not run into issues with humidity and moisture, and that can affect things in this equipment. So be very, very careful on that, okay? Let's see. Mike B says he has not had any Corel EEVs fail. Don't overpressurize the system when testing for leaks. So he's referring to the Heatcraft expansion valves that they use, the EEVs. They're made by Corel. And I can attest to his point. You don't want to overpressurize the system when you're doing a nitrogen test. You want to make sure that you are flowing nitrogen when you're doing the brazing and the install. Heatcraft actually ships their Corel EEVs in the open position, so you do not want to apply any power to the evaporator coil or the condensing unit until you are done with all of your brazing. You can flow nitrogen from the high side into the low side as long as you have a normal system, and purge it out the low side or whatever while you're brazing. The EEV is going to be in the open position, okay? They also make special magnets, or you can take the stator and rotate it to get the valve to open and close for different reasons. But you can buy Corel EEV magnets. There's other manufacturers that make EEV magnets too if you need to open up a valve. Let's see what else we got going on in the chat right now. Reading through here. That's for pressure transducers that overpressurize. And yes, exactly. And I've made that mistake, as Mike is alluding to, or he's talking about. I've made the same mistake where I overpressurized a pressure transducer and damaged it to where it was reading way out of whack, causing low superheat, flooding back to the compressor, causing issues too. So it used to be like 150, but like Mike says, they've adjusted it, and their limitations are 250 PSI now. Question I got the other day that I thought was an interesting one that I should address is, why in the heck, when am I charging a system that takes R22, why in the heck am I charging as a liquid refrigerant? Oh my goodness gracious, I'm going to blow up the compressor because I'm charging with liquid refrigerant. As a technician, okay, you're going to realize that all of the blended refrigerants, you are supposed to charge them as a liquid. R22 obviously is not a blended refrigerant, but I have gotten into the habit of just charging every refrigerant as a liquid. That way you don't ever make a mistake. It's muscle memory to me now. Whenever I charge a system, just flip the cylinder over as long as it needs to be flipped over. And I'll tell you, because there was some R12 retrofits out there, mainly some of the original cans of Hot Shot, which was an R12 replacement, a drop-in. They had a dip tube in the cylinder, so you didn't flip that tank over. So you always got to pay attention to what's on your cylinders. That way you know what you're doing. But I charge everything as a liquid and just call it a day, and you just meter it. You got to use your skills. You got to use your brains. You don't just open the valve and just let it dump while the compressor is running. You meter the refrigerant using the valve on your manifold gauge set, or the ball valve on your probe hose, or whatever you're going to use. So yeah, I've just always charged everything as a liquid just to eliminate any issues or concerns. Someone is asking me, if they had a 20,000 square foot walk-in freezer, what would be the best control strategy for that freezer? And in their question, they said, would I recommend an Emerson E3? It really depends. I mean, your control strategy for a 20,000 square foot multi-evap freezer really depends on the type of equipment you have in there, right? And what you want out of it. The Emerson E3 is a remote monitoring system that has capabilities of data logging and telling you information from a single point, accessing it via the internet or whatever you have it hooked up to. It just depends. I mean, what do you want? You know, you can go with a smart evaporator controller from KE2. You can use Heatcraft's intelligence system. You can use, I mean, there's the sky is the limit on the different types of control packages you can use on this equipment. So it really comes down to what's available in your area, what you are comfortable working with, and what the customer's needs are. Do they want data monitoring? Do they want to spend $4,000 or $5,000 on an E3 setup to install it and have all the monitoring? Or do they just want to have, you know, a KE2 or, you know, a Sporling controller in there? Who knows, you know? So it really just depends on the customer. I'm not going to go throw an E3 on something that is just a walk-in freezer that the customer is not monitoring or anything like that. It seems like a little waste of money for that, in my opinion, but I could be wrong on that matter. So Disc Tech says Jason Johnson. I mean, there's so many different things. So do I have simple heat load calculation for walk-in boxes? Do I have a simple heat load calculation for walk-in boxes? I will use the heat load calculation software that the manufacturers have, heatcraftrpd.com, and you can download the hub on your phone, and you can download the hub app for your computer, and you could do refrigeration load calculations on there. It's really easy. You can go to the Sporlan virtual engineer, sporlan.com, and then click on the virtual engineer tab, and you can do line sizing, valve sizing, all that different information. It's all available using the software. So I don't use like a paper quick load calculation. If I'm going to do a load calculation, I'm going to do a proper load calculation based on every single different restaurant location and what's going on in their kitchen. So Keith Peterson, thank you very, very much for that super chat. That is very nice of you. Much appreciated. He says HVACR gear is the lady's choice. So he's referring to my merch that I have available on my website, hvacrvideos.com. You can get hats, beanies, all that good stuff. That was very nice of you, Keith. So thank you very much for that super chat. And again, thanks to Pat Finley for giving one too. So let me see. You should see how much it costs to add building automation system or retrofit a building. Yeah, for sure. Proper control system really comes down to how good the tech that actually programmed it. Ask him how he knows. 100% will speed. I mean, the same thing goes for installing and commissioning any piece of equipment too. It really comes down to how well it was commissioned and installed, and how well it's going to operate, and what the issues or potential problems are going to be in the future. So, all right, let's see what else we got going on in here. Is there a reason in my recent video where I think I said the family dinner had to wait was the title? Is there a reason that that particular walk-in cooler that was not working, I mentioned that the evaporator had electric defrost, and the evaporator was controlled off the 3-phase breaker up on the roof? Why in the heck did they have a medium temperature walk-in cooler that was controlled off of the rooftop equipment and also had electric defrost, and the evaporator coil fans were 208 volts? Why? I don't know. The engineer at Masterbuilt, or whoever spec'd the equipment, the salesman that sold them everything, gave them a 208 volt walk-in cooler evaporator. Electric defrost is overkill for a walk-in cooler. No need for it. And in fact, most electric defrost and walk-in coolers end up being nuisance issues if they're not installed right and the limit switches aren't installed right. If they're not a smart evaporator, you have to buy special fan delay defrost termination switches, because the evaporator won't get to 20 degrees to turn the fans on fast enough, and you'll end up flooding back to the compressor. Especially that'll be a problem if they don't have accumulators and stuff. So speccing electric defrost for equipment that doesn't need it is just kind of silly in my opinion, and doesn't need to be there. Why this customer had it like that, I don't know. You know, it's just whatever the salesman sold it to him. Can I explain the TXV a little bit more thorough? Edric, that is definitely something I can work on. I'm not going to do that right now, just off the top of my head. But I can try to do something a little bit better, or point you in the right direction. So do me a favor, Edric, shoot me an email to hvacrvideos@gmail.com. I'm going to highly encourage you to go check out hvacrschool.com and look up TXV operation. That is Brian Orr's website. He has a great team working for him, and they probably can do a much better job of explaining all the functions and operations of a thermostatically controlled expansion valve with proper terms, much better than I can do. So, Christian says he wants to get into ice machines, and they seem relatively simpler than refrigeration and AC. What sources do I recommend to learn them? Well, I'm not going to say they're any easier. The problem with ice machines is a lot of their installation information, their service information is proprietary to each manufacturer. So you have to go to the manufacturer's training classes. The cool thing is most major brands of ice machine, Manitowoc, Manitowoc, Isomatic, Hoshizaki, Scotsman, Fullett, Vogt, shoot, I'm sure there's a few more. True now has an ice machine. All those different brands, all their information is available online, and you can go to their different various websites and download the information and find their service manual. So that's a really good way to learn. Then usually between January and probably April, in my area, they do all the ice machine training classes that may be regionally specific. So reach out to your local distributors that sell the ice machines, and they'll tell you when the training classes are. If you want to get super in depth, I'd highly encourage you to go to a factory service school. So there's regional service trainings that are usually like a half day class or a full day class, and they usually give you lunch and just kind of give you a marketing spiel and the general basics on the ice machine, right? And then you have the actual factory service schools that are usually anywhere from 4 to 7 days long. For Manitowoc, you travel back to Manitowoc, Wisconsin. For Hoshizaki, you go to Peachtree City, Georgia. Fullett, I don't know where you go for Fullett, to be honest with you. I've done some Fullett training, but anyways, each manufacturer will have different training things. They're quite expensive, but they're totally worth it if you really, really want to understand the operations of those machines. Would I say that ice machines are easier than refrigeration? Not really. All the refrigeration components are in an ice machine. So, I mean, there's a lot going on in an ice machine for sure. Do I partner much with out of California contractors, even just info sharing Canadian, just wondering about culture down in Cali? I don't really partner with any out of California contractors other than making these videos and sharing the little bit of knowledge that I have with people around the world like yourself. But no, I don't really have any partnerships that I have with other contractors. I mean, I have friendships, I have friends that do the same kind of restaurant work in other parts of the country, and we'll just call each other and just be like, hey, have you run into this problem at this restaurant? And they'll tell me, yeah, and give me their fix, or I'll do the same for them. So, I mean, we have friends that we lean on and share information to for sure. Keith Peterson says TXV and women are basically the same. That's pretty funny, actually. Arika Anderson, thank you so very much for, you said that you bought some merch from my website. That is very awesome. I really appreciate it. Thanks so very much for that. So let's see what else we got going on in the chat. Jason Johnson loves ice machines. He can tell you anything you need to know. There you go. In December, Jason says he's going to train in La Crosse, Wisconsin for factory chiller training. That's really awesome. Yeah, anytime you can get training. Look, here's the thing. Is the factory chiller training for Trane going to make you the best trained chiller technician in the world? Maybe, maybe not. Is that training, worth every penny you're going to spend on it? It really depends on what you make of it. But the best piece of advice I can give anybody out there is any training and or any certification is better than nothing, than no certification, right? Bettering yourself, growing your knowledge like Jason's doing, becoming more valuable is good for the company he works for, and it's good for him because when he leaves that company, that knowledge is still his to keep forever, to retain. Okay. So any training, any certification is better than no certification or no training. So take everything you can get, especially, and the older guys that are in the chat right now and watching this, they'll, I'm sure, agree with me. As you start getting older, right? I'm just in my 40s. I turned 41 yesterday, right? I have a lot less time to spend going to training classes. It's harder and harder because I have a family and a business and all this different stuff. I regret not going to more training classes when I was younger and I had all the free time in the world. I regret not doing that then. So I encourage everybody out there, especially the young guys, take the time, better yourself, grow your skills, grow your knowledge, absorb everything you can, right? And keep learning. Don't just stop. Keep going back. I really, really want to go back to school. I've said this before and I'll say it again. Just for the heck of it, I want to start HVACR school all over again and start from the beginning and take a basic refrigeration class and work my way through the program again. Why? I don't know. Just because I want to fill in the gaps of proper terms and different things that I don't have. I would love to do that if I can find the time. I would absolutely love to do that. All right. Can you talk about gravity coils versus forced air evaporators? So I'm not going to be the best person to talk about gravity coils, okay? But I will tell you that gravity coils are going to rely on convection. They're going to rely on hot moving to cold, right? and air moving around. So, you know, you've got an evaporator at the top of an open gravity or static deli case. You know, the theory is that the warm air is going to gravitate towards the cold coil, and then the cold air is going to fall down to the bottom of the case and cool the product. But want to get into more depth about gravity equipment, you know, gravity cases and different things. You probably want to go a little bit more in depth. I'd reach out to Brett Wetzel, Kevin Compass over the Advanced Refrigeration podcast. They could probably help you out a little bit more. Some basic stuff I can tell you is, you know, before you diagnose anything, before you adjust on anything, before you add refrigerant to anything, make sure your coils are completely clear of ice and frost. You know, on a gravity system, you're typically not going to have fan motors, so you don't have to worry about that. Make sure your strip heaters on gravity cases are usually electric heat. Make sure they're not energized or stuck on or something like that, you know, and be cautious. But yeah, definitely check out Advanced Refrigeration Podcast. They could probably help you out a little bit more on the gravity stuff. So let's see what else. Oh, right on, Matt. That's awesome. Matt says he's going to be getting a hat this week. That's really cool. Yeah, my wife just put, I saw her processing some orders, and she had like 3 orders or something that she was getting ready to take to mail out. And then I know she mailed some out on Friday too, I think. So Bill Russell says he doesn't think he's ever seen a gravity case in person. Yeah, I just got rid of my last gravity case, to be honest with you. Why are some blower fans backward bladed and others forward bladed? Again, it really depends on the engineers and what they're trying to do, whether they're trying to pull air or push air for some reason. It just depends, you know. And then sometimes too, they might be having fans blowing in different directions, because you could have evaporator fan motors, and then you could have sweep motors that are moving air across the glass that it might be heated to try to prevent condensation and different things. So when you're dealing with cases, that's when it really starts to get tricky, and you got to make sure that you use the right motors, they're moving the right amount of air, the blades are on right, coils are clean, the honeycomb's clean. I mean, it really starts to get interesting when you're working with case coils. Let's see. Reading through the chat right now. Do I have a favorite piece of equipment I like working on? I just like troubleshooting. I will say that oftentimes what I find, the most difficult service calls, the ones that give you the most grief and give you the most headaches, they end up being some of the best learning lessons, in my opinion, when I deal with things. And when it's all said and done, so once you get it all figured out and everything's operating, you pull the tail out from between your legs and you're happy, you know, you got it fixed, then reflect on it and realize how you could have made it more efficient. But oftentimes those are the biggest learning lessons for me. The most difficult calls are the ones that I learn the most from. But what's my favorite piece of equipment to work on? That's a really hard one. You know, shoot me an email, hvacrvideos@gmail.com. I'll try to think about it a little bit more, give you a more honest answer on that one. Dave Johnson says, still have a built-in salad box. Yeah, I forgot about salad cold rails and different things. I have a ton of cold rails that are static or gravity. Well, they're not really gravity. I guess they are, but they're static ones where it's just a cold plate with no fan motors. I deal with those a lot too. All right. Kyle says, ever had a compressor go bad once the unit came on, but before you turned it on and checked for ground and ohms as well as continuity? Wait. Ever had a compressor go bad once the unit came on, but before you turned it on and checked for ground? Oh, okay. So you're saying that it wasn't grounded, it had continuity, but when you turned on power, it was locked up, I'm assuming, right? It might have good resistance. It might not be grounded if the compressor is just mechanically broken inside. And if it runs stuck, locked up, it'll oftentimes go off on locked rotor amps, trip a thermal overload, and then not have continuity. But once you let it cool off, it might have resistance again. It's just internally locked up. There's always the odd chance too that the electrical failure happened the moment you turned it on. I mean, stuff does happen, you know. Don't ask me about brazing. Yeah, I guess not. All right. All right. Why did the system? Oh, okay. So on the walk-in cooler video, the one where I said the family dinner had to wait, when I was all done, I changed a defrost clock on it. And when I went to go put it in defrost, it wouldn't go into a defrost. So why wouldn't it go into a defrost? Because it had electric defrost. When you have electric defrost, you're going to have limit switches built into the coil that won't allow the defrost to run, the electric defrost, if the coil is too warm. The customer had called me out there saying the box was at 55 degrees or whatever it was. Well, that fan delay / defrost termination switch, which is the limit switch inside there, acts as a safety. It doesn't allow the evaporative fan motors to come on until the coil gets below a certain temperature, but then it also doesn't allow the defrost heaters to run if the coil is above a certain temperature either, because there's no sense for electric defrost if the box is 50 degrees. It's just a waste of energy and it's going to melt some things, right? So it's just simply because the evaporator coil was too warm. And like I said in the video, the limit switch was doing its job because it wouldn't go into defrost. I did a video recently where I changed an exhaust fan on the roof, and I got quite a few people commenting that I was a baby because I used a crane and because I didn't rope it up the side of the building. Or, back in their day, they just used to rope everything up, and, real men didn't have to use cranes. Those real men are probably hurting right now, and bodies are broken and they're beat down. I'm one of them. I used to do the stupidest stuff in the world. I used to rope everything up a side of the building, and I'll still rope some things up. But when it comes to an exhaust fan that's big and large, nobody needs to be standing on the edge of a roof, leaning over the side, trying to pull a exhaust fan. It's not really the weight so much on that exhaust fan as it's just large and awkward. So why did I use a crane? Because it was the smart thing, and I put it in my bid, and the customer approved the bid, and I didn't have to lift it up, and I didn't have to do anything sketchy. Okay. I've done too much sketchy stuff in my career. I don't want to do it anymore. So we use a crane whenever possible. I also have a manual equipment lift that it has outriggers that come out, and it's like a ice machine lift, but this one will actually go up 26 feet in the air. I'll lift exhaust fans on the top of the building using that too. Sometimes it's easier, sometimes it's not. It just depends. But I'm typically not pulling things up the side of the building unless it's like a super, super lightweight exhaust fan. Let's see. Do I use my own offer code on TrueTech tools? Yeah, I will. I will use my own offer code for sure. Reading through the chat right now, seeing what I'm missing. Have I ever had a soft plug blowout on a computer? Oh, compressor. No, I've had on the Carlisle compressors, they have a braze point on there that they braze one of the plates inside there, and they were notorious for leaking out the side. I've had those blow out, but I've never had a soft plug blow out. I've had soft plugs leak on like receivers and different things for sure. Yeah. A soft plug typically is a emergency pressure relief point that they put into a lot of equipment. It's a temperature. So basically on receivers, oftentimes you'll see it. If the receiver temperature gets above 430 degrees, it will melt the soft plug and vent the refrigerant charge before the receiver, a pressurized storage vessel, catastrophically fails and explodes. They'll have a pressure relief device. Sometimes they'll have mechanical pressure relief devices. Sometimes it's just a weld. There's different ones. Let's see. Reading through here. Okay, I already answered that one. John says, had a reach-in compressor tripped breaker instantly, but compressor checked out okay with a meter. It wasn't locked up either. First time that's ever happened. Replace the compressor. Yeah, that's a very interesting one, John. I don't know why. Yeah, very interesting, though. Bill is, my buddy Curious HVAC guy, is feeding a baby and watching the stream. Yeah, so Bill just had a baby. Yep. He did one of those transition surgeries and had his own baby. No. Bill's wife had a little baby, and Bill is still on the maternity leave or whatever you call that when the daddies take the time off. So he's spending the much needed time at home and helping his wife with the baby. So that's really awesome. I bet you it was a pretty cool Father's Day having a brand new baby at home. Congrats, Bill. All right, let's see what else. Reading through the chat. All right, cool. Yeah, it's awesome to see everybody in here again. Paternity. There you go. Maternity. I said maternity leave. It's paternity leave. There you go. Or Paid Family Leave Act or whatever it is. What's the purpose of a sight glass in a system? So a sight glass is a window into the system. You can have a sight glass on a compressor that'll tell you the oil level. You can have a sight glass on a liquid line that'll tell you the refrigerant state at the point that it's installed. You can have a sight glass up on the roof right before the expansion valve. Sight glasses are literally just a window into the system to tell you what the refrigerant gas is doing in the system at that particular point that it's installed. In a perfect scenario, you install a liquid line sight glass right before the expansion valve, but it's also not very practical because then you got to be inside the box to check the charge. Doesn't really make sense. Oftentimes you'll see a liquid line sight glass installed up on the rooftop equipment. And when you're charging a refrigeration system, if it is a refrigeration system with a receiver and a thermostatic expansion valve and even an EEV, you charge it via the sight glass. You do not charge it via superheat and subcooling. Now, I'm not saying that you don't pay attention to superheat and subcooling, but you don't use subcooling as a metric to charge a refrigeration system that has a receiver. Okay. You use the sight glass to tell you what the state of the refrigerant is, but you don't just use a sight glass. You also look at the pressures, you look at the temperatures, you still look at the subcooling and the superheat, because subcooling on a refrigeration system with the receiver can tell you if a system is massively or grossly overcharged. Yeah, it'll tell you that. But oftentimes on a refrigeration system with the receiver, you're not going to see very much subcooling measured coming out of the receiver. Okay. Liquid and vapor exist in that storage vessel, that receiver. You have liquid down at the bottom, you have vapor at the top, and that liquid is pushing down on, I'm sorry, that vapor is pushing down on the liquid, and the liquid is being pulled up by a dip tube and running out the other side of the receiver. So you have two states of the refrigerant inside that receiver, and you're typically not going to see very much measurable subcooling. So if you charge a refrigeration system with a receiver to 10 degrees, 12 degrees subcooling, you very likely have massively overcharged that system. Now, that is not a one-stop, be done charging method, because then you have to worry about low ambient controls, head pressure control valves. Those require extra refrigerant beyond a clear sight glass. But also, it's not just to clear the sight glass and move on. What do you do before you charge any refrigeration system, whether it be an air conditioner or a refrigeration system or an ice machine? It's heat transfer and airflow before charge, right? So if it's an evaporator moving the air across it, you need to make sure that the evaporator is not iced up. It's not dirty. You need to make sure the condenser is clean. The condenser is not dirty. So you don't just charge a system because you see a sight glass flashing. If you have an iced up evaporator downstairs, your sight glass will flash. Okay. The evaporator is going to rob the refrigerant, and that refrigerant is going to sit down in that evaporator, right? It's not going to change state. You can also flood back to the compressor if you have a partially iced up evaporator, because the heat transfer is not happening. And when you feed refrigerant through an expansion valve into an evaporator, it's not just vapor coming out of that expansion valve. It's a vapor liquid mixture. It's saturated. Okay. But as it leaves the evaporator, as the gas passes through, so it comes out of the expansion valve as a saturated state, liquid and vapor, right? But as it's passing through the evaporator is absorbing heat, and it's helping to completely change the state, the phase change of the evaporator, change it to 100% vapor. Then it should be going all the way back up to the compressor as vapor. If you have an iced up evaporator, you can be sending liquid back to that compressor, because if it's partially iced up, it's not going to have proper heat transfer. That's going to cause the sight glass to flash. That's going to throw things off. So it's not just a sight glass is flashing, add gas and move on. No, you got to look at the big picture. You got to look at everything, right? So airflow before charge, make sure the coils are clear. Same thing on air conditioners. Make sure the filter's clean, you know, all that good stuff. Ductwork's not undersized, everything. Reading, see. Most new walk-in cooler condensers have head pressure control valves. Now, coolers and freezers have to charge accordingly. That is correct, Mike B. On another note, to add more complexity to it, most new condensers for the walk-ins have an added subcooler loop. So you actually will get measurable subcooling coming out, but it's still not what you charge to. So oftentimes on the newer systems, you'll do a pass coming out of the compressor. It'll come out of the compressor, go into the condenser, come out of the condenser, go into the receiver, come out of the receiver, then it'll go back into the condenser, go through a subcooler loop, then go down through the sight glass and dryer and go down to the expansion valve. So you actually will get a pretty good measurable subcooling on there. But again, it's not something you use to charge. It's just that extra subcooling loop to make sure that they have a full column of liquid going down to that expansion valve. And that's the really important thing too, is expansion valves work off of liquid refrigerant. They don't do very well with vapor. So if you feed saturated refrigerant to an expansion valve, right, it's not going to do so well. Or if you feed vapor to an expansion valve, it's not going to do so well. It needs to be a solid column of liquid for it to work right. There's a few manufacturers that kind of beat to the tune of their own drum, so do be cautious about that. There's some manufacturers that don't run a solid column of liquid to their expansion valves, but they've done some massive engineering and they know better than we do. So just be cautious about everything. All right. Reading through the chat. Okay, cool. So what are my thoughts on the new DOAS and or captive air package units? A gentleman had asked me because he watched a video. I watched the same video from Captive Air on their DOAS units, where they say that their DOAS units, which can act as 100% dedicated outside air systems, they can act as 100% outside air, or they can act as a package unit, okay, depending on how they're set up. But Captive Air, they have some, if you haven't seen Captive Air's videos on YouTube, they actually have some really well edited and well shot videos with lots of great valuable information. They have like a full production crew that runs their YouTube channel, and they have some great videos. So Captive Air, go to their website. But apparently I highlighted your comment there, the good guy. So that's cool. But yeah, they had a video where they said that they engineer their DOAS units to have a 25-year shelf life. They want the components in the system to last 25 plus years. Do I think that's practical? I mean, I guess, I don't know. Realistically, if you're not conditioning the power, if you're not filtering your air, if you're not designing your system right, it's not going to last 25 years. But if you're bringing proper power into that unit, it has surge protectors and everything on it. If you're designing the ductwork properly and you're getting proper airflow to and from the unit, and if the unit is engineered and sized correctly and installed correctly, you might get 25 years out of it. Maybe, I don't know, you know, but it does look very nice equipment. The one thing about Captive Air, and they're working on it right now, is they don't have, as of last I checked, they don't have factory service training on their DOAS units as of yet. They call them Paragon units, but they are working on it, and they're supposed to. So they have internal training, and they'll give you tech support over the phone, but they haven't, as far as I know, they haven't done any classes yet, at least not in my area. And I've been talking to a few people at Captive Air, and they've been sharing the information. So they look like really nice units. I just haven't serviced any of them or worked on them yet. So let's see what I got going on in the chat right now. What am I missing? Microchannel leaks. Stare at it, and then it leaks and laughs at you. Yeah, 100%. Microchannel can be fun. Why did we go to microchannel coils? I want to ask the chat right now. Why on the non-microchannel high SEER units do we have so many refrigerant leaks? And why on the microchannel coils, why did we even go to microchannels? Why do we have so many leaks on the microchannels too? I want to see if the chat has any answers for that one. I'm going to answer another question while they're answering that. Why do the stores that I work at, the restaurants, use circuit breakers as off switches? Because they don't listen to me. And, you know, it's just one of those things. It's easier for them to find a breaker than to climb up on a ladder to flip a switch for an evaporator coil. They're just silly. Okay. So just one of those things. Efficiency and cost, says Mike B. Microchannel has greater surface area to volume ratio. Total charge amounts hold a lot less refrigerant on microchannels. John L says better heat transfer. Another human says smaller condensers are needed. Yeah, all those answers are correct. Okay. Efficiency and cost is really what it is. So to gain better efficiency, we've thinned out our copper. On a tube and fin coil, we've made the copper thinner. If you guys go find a condenser coil from the 1980s, 1970s, and you cut it open and you look at the copper, you look at the thickness of the copper, and you go cut a condenser coil now, and you look at how thick the copper is, the wall, once you cut it, you're going to see a drastic difference, okay? The new copper is super, super thin, almost paper thin. And it's very susceptible to refrigerant leaks, but they do that to get better heat transfer, right? Because it's more efficient if the copper's thinner, because it can absorb and reject heat a lot faster and a lot quicker, and it doesn't have to work so hard. But then on top of the microchannel, it's kind of the same thing. They realized that in the automotive side, they were doing really good with radiators and different things, and they were very efficient. So they started moving that into the air conditioning side. There is some downsides. If it's not installed properly, if it's in a harsh environment, if there's a lot of vibration, they tend to run into leaks. Cross my fingers. I haven't had a crap ton of microchannel leaks. I've had a few, but nothing too crazy. So, see what else we got going on in here. Oh, wow. That's really awesome. Matt Woodbridge, thank you very much. It says he gifted one HVACR videos membership. That was really cool. And it says he gifted it to Scott Savage. That was really cool. That was very nice of you there, bud. All right. The copper is now barely thicker than Reynolds wrap aluminum foil. Yeah, that's right, Tom. 100%. You are correct. Let's see. You wish they used rifled tubing and condenser coils that are tube and fin. Yeah, 100%. Reading through the chat right now. Okay. So when I walked up, so the video that I made on a walk-in cooler where it said the family dinner had to wait, right? And when I first walked up, if you guys watched the video, when I first walked up to the equipment, I opened up the electrical panel and I said I was checking voltage at the time clock, and boom, the system came on. And that's when I realized I was also assuming the wrong piece of equipment. But when I actually checked it on the right one, that's when I realized, hey, it just came on. So I mentioned, I think there might be something wrong with that time clock, because the moment that I touched it, I heard the relay click. Why then, the person is asking me, did I go directly to cleaning the condenser? Because when the system was, I heard the system operating. When it did run, it instantly shut off on high pressure. I didn't know for sure if the time clock was going to be a problem. I had a hunch, but I knew for sure that the condenser was dirty. So we start with the low-hanging fruit. It might have a problem with the time clock, but I definitely can't even diagnose the time clock until I clean the condenser and get the system operating properly. So you got to think about this stuff and try to be as efficient as possible when you're troubleshooting. If I'm up there on the roof and, in that situation, it's like, okay, I might have a bad time clock, but my system's going off on high pressure. I need to fix the high pressure issue first, get that going, and then you can troubleshoot further. That's the way that my brain works. Let me have a drink of this real quick. And of course, I drank that wrong. Now I'm going to cough for the rest of the stream. Okie dokie. Let's see what else we got going. Multiple offender systems need triage. That happens quite often. I'm currently dying over here, so all right. Well, that is it. I realize it's 6 o'clock. It's time to wrap this up. I try to keep these things at 1 hour. Remember, I go live on Monday evenings, 5 p.m. Pacific, typically on YouTube on this channel. Also go live on the HVAC Overtime YouTube channel Friday evening, 6:05 p.m. Pacific, with my buddy Bill Russell, Curious HVAC Guy, Adam Muffich, A-Team Adam, HVACR North, Joe, who's in here, and myself. And we go live on the HVAC Overtime YouTube channel. Maybe if someone gets an opportunity to throw up a link to the HVAC Overtime YouTube channel, you guys should definitely go subscribe. I have one caveat. If your feelings get hurt instantly and you don't like people making fun of people, if you don't like people saying inappropriate things, if you don't like guys acting like idiots, if you don't have a sense of humor, you definitely don't want to listen to the HVAC Overtime show. It is very uncensored and very offensive. It's not safe for work, but we have a blast. We laugh. Bill always pushes the buttons and says very uncomfortable things that we shouldn't laugh at, but we do. It is just a good time. Definitely want to check out the HVAC Overtime show. I really appreciate you all. I'm going to, let's see, Marat, answer his question real quick. He says, how's my customers doing on paying bills nowadays? Just wondering. I don't really have any mom and pop restaurants anymore. And most of the customers I'm dealing with are commercial. They are hit and miss on paying their bills. We had some rough times going on from like September till January of last year, or to early January of this year. I had some issues with some customers, but they all got paid up. And for the most part, we're doing okay right now. But yeah, I'm not really doing much mom and pop stuff right now. I only have like 1 or 2 mom and pop customers, and they pay very well. So yeah, right now is a rough time. A lot of people are having to collect payment up front. I don't have to do that, but I have heard of some people doing that, collecting deposits and payments and stuff up front, which customers don't understand. It's a whole mess right now, but yeah, I wish you the best on that one, Marat. So, but yeah, I'm going to bring in the dogs here in just a minute. So I'm going to cue up the outro music. I really appreciate you guys, and we'll see you with the pups here in just a minute.